At the end of September, I was on AWS conference, re:Invent, and I was on the keynote when they announced support for Golang in an AWS Lambda. And I really like this technology, so I decided to talk to you about it today. So my name is Tomáš, and I work as a platform engineer at kiwi.com. I hope you know kiwi.com. Research Flights, it's a website. And what is the serverless? Serverless is like you can go on Hacker News and try to search for it, and you will find a lot of results. So it might be a new buzzword. For me, it's anything that you don't have to provision or manage, and you are usually charged per usage. Since you don't have to manage it, so you can like fire your ops team. Not really, as we will see later. And what really like started whole serverless movement, it was function as like managed service on AWS. Actually, I should ask, do you know AWS? Yeah. Cool. Do you know Lambda? Do you know Lambda and Go? Has anybody tried Lambda and Go? Good. So on AWS, it's AWS Lambda. It's just another Linux container. So how it works? There are usually some events that triggers that container. That event could be directly you can invoke the Lambda, or it can be, for example, object creation on S3, or like DynamoDB changes if you have some changes in a table. API gateway, that's really handy if you want to build a REST API with your Lambda. You can define it there, or like it will handle a step like request limiting, your endpoints and so on. Cognito, you can hook up Cognito to API gateway, and it will talk to your Lambda, and it will help you to authorize your requests. And there's like 15 other sources or more. Oh, sorry. So with Lambda, that's like the computation power that will handle these events. You can write it in Go and other languages, and from Lambda you can do like whatever you want. Call another Lambda, do something in cloud. So what is the life cycle of this Lambda? It starts in a code state. Then when it's triggered by event, it goes to the hot state. It processes the event, and when event is processed, it goes to warm state, where it waits for a while, and then it goes back to the cold state. If it's in a warm state and it's triggered by an event, it goes like it processes that event a little faster. People say that lambdas are stateless. That's not really true. During like this period, they can have a state. That state is local to the container, and you can't really depend on it, but they have a state. And thanks to this process, it automatically scales. So you don't end up like this guy, where this is his Kubernetes cluster, and this is his blog here. And it's also really cheap, I mean, like dirty cheap. Like you can get 18 days and 6 hours of computational power for the price of single Big Mac. It's like really cool. Also, you get visibility for free, so everything is logged, like request, like when it begins, when it ends, how long does it take, what memory it consumes, all your logs. You get instrumenting for free, like number of requests and so on, and distributed tracing. You can enable distributed tracing in like one line of your config file. It has some limitations. The task should be really short very short. Memory is from 128 megabytes to 3 gigabytes, and based on this memory, you will be charged more. You can have a disk, actually. It's really small, and you have some limitations for how many lambdas can run concurrently, but this limit can be increased. So, if you want to try Lambda with Go, you should go to this repository, and you will find there a few packages, and I would like to go through them. Like, they released this in 15th January, I think, so it's quite new thing, and I really didn't try it all, but I will tell you something what I've learned. So first package, the Lambda package, it contains the method start. It takes empty interface, which is kind of shame, and you can call it like this. So you have one main function, and you initialize the Lambda inside of it. And what is that handler? That handler can't be really anything. It has to satisfy one of these definitions. On their website, it's written like it takes from 0 to 2 parameters and returns from 0 to 2 parameters. First parameter should be context. The last parameter has to be an error, which is kind of weird. I think that they should use the interfaces for them, and it will be more clear. So I will start from the beginning with an error. So it's just standard error. So if you will return an error from your function, it will be serialized into an event, which is quite nice. We can also panic inside our function, which will be serialized like this with a stack trace. It's also cool. About the context at the beginning, it's just standard context. You can, if you have some long-running handler, you can just nicely finish it before the timeout. Also, it contains more information about like memory limits, where it logs, request ID, and so on. If you want to work with it, you will use another package, which is called Lambda Context. Now the interesting stuff. The T-in and T-out, these are like any types that satisfies JSON Marshall and JSON Marshall interface. And lambda.start will start a handler and listen for the events. And it will JSON unmarshal and these events from JSON and pass it to your function, and it will take your results and just unmarshal it and send it back as an event. If you want to invoke your Lambda directly, you can just use your events, use your definitions, but for talking with, for example, API gateway or S3, you have to use, you should use one of types predefined in package events. So, for example, if you want to have a Lambda function that handles some endpoint in API, you will have a handler like this, where you will receive an event from API gateway. It looks like this. So it's string over string with maps from string to string, which is not really nice. And you have to do a lot of stuff by yourself. So for example, in the body, if you have a post request and your body is JSON payload, you have to unmarshal it by yourself, or the query string parameters. It's kind of weird because Curial schema is using map string to string array, so you can't use it easily either. And you will have to handle a lot of stuff here. If you want to respond, it's easy. We'll just set the status code, marshal your request in the body, and set some headers. Okay, so now let's say that you build your application with lambdas, but you need to build it. So how would you do that? We will literally take that binary and put it in a zip file So you can do it like this, cross-compile binary and zip it. Like pro tip, you can use ldflex, SNW, that omits the verb symbol table and like debug stuff, and that will reduce your binary size. That helps a lot during the code start because of the total image is smaller. Okay, so now you build it, you wrote it, build it. Now you want to run it locally. How would you do that? For this, I will have to like step aside a little bit. Have you heard about CloudFormation? Yeah. Do you like CloudFormation? So, serverless application model. It's called SAM, and it's a transformation on CloudFormation. CloudFormation is something like Terraform. You know Terraform? It's just your code as a infrastructure as a code, and it works on AWS. That's like because CloudFormation was released way before serverless was a thing, so they did this transformation for CloudFormation, and it helps you to deal with the lambdas easily, manage your API gateways and these things. So you would create some template.yaml in your directory, and this is how it looks. So on the top there is like this line that tells you that this is the SAM, not the CloudFormation, and then you define your resources. So you will name it like hello world. You will say that's your function. Set some properties. You can set the runtime is Go, name of the binary you build. You can set some parameters and path to your URL. Okay, so now if you have the SAM template, you can use some local tool which uses the curve to mimic AWS environment on your local machine. It's just command line tool, and you can call, for example, SAM local start API, and it will look into your SAM template, find all functions that talks to your API gateway, and mock that API and like start it as on localhost. You can also invoke your function with any event. The help function is like reference to the resource name in the SAM template, and that event is just any JSON. If you want to mimic like even from, for example, here from API gateway or like S3, you can use generate event, and it will help you to generate an event. These JSONs are usually like really large. Okay, so you can test it locally. You are quite confident if you want to deploy it. So some local will just wrap a CloudFormation. So you can first call package, CloudFormation, the same command practically. This will just upload your code into some S3 bucket you define, and inside the pack.yaml it will paste there. It will paste there the S3 links for your code, and then you call SAM local deploy, and you will give it a stack name for your CloudFormation stack, and this will deploy your application. Okay. So any questions? I would like to do a demo. Okay. Is it okay? You can see this? So I have my directory here. I have a simple function in Go. So I will work with API gateway. I will receive a post request with name and age, like do some basic checks, and like this line, I will format hello, that name, your age is, and your age, and return the response. It's like here I'm starting the. There is one parenthesis also like this. I wrote a single test for convenience. Cool, it works. So now I want to like test it locally. So I have my template. Here I defined some basic stuff I showed you, and also I defined that on a root path. On the root, it will take a post request. So let's build it. Compilation. Okay, so I can start the API. So on this address, should have the API. So cool, I have it here. So I'm sending post request with the name Tom and age is 26. The endpoint and returns like hello Tom, your age is 26. Nice. It also logs. Okay, where's the green things? This you would see in your CloudWatch as logs. You can see, for example, when it started, how much memory it consumed, how much memory they requested, and the duration of this task. So if I want to test, just that event, I will generate event as I showed you in the presentation. I can invoke it, and it should do the same thing. Okay, so now I test it. So if I want to deploy it, I will upload that code into my bucket. This will take some time. So now would be great time for questions if you have some. No? Yes?
You showed that it shows statistics like how much milliseconds it took, etc. And I would like to ask that, does it even compute the price for server requests, or it's just on your own when you see these results? Price
like right now when I test it?
Yeah, like some basic price for per request. And to just type how much requests you probably will have.
It's going to be here. So there is a build duration.
Yeah.
That's 100 milliseconds. It's like it's built for each 100 milliseconds. And I can check the pricing. It's like first of all, first million requests are for free, and then it's like 0.6 or 0.2 dollars per this function. It's like really cheap.
Yeah,
Okay.
basically I was asking that if it shows something like this, or
No.
it's up to me to.
Yeah, it's up to you. But actually, all of these, okay, it's created. Like everything, all the information, how long does it take to run this function, are logged. So you can then process your logs and see, for example, for which request you paid how much money. So now I will go to okay, hope it's big enough. So I can check my lambda. Should be here. Okay, it's my lambda. For example, I can test it directly in a web console. It's quite nice. I can also generate here even for API gateway. Here I can set the name Joe. H score. Oops. Create this test, run it. I see that this went well. It returns the message. You can see these logs here. I can go directly to the logs actually. So there would be like all calls to that function. If I will check the API gateway. So there's my one endpoint post stages. If you look at that API, actually, you can set that message. Okay. So when I hit my API, it works. If you would start sieging this API, it would be fine because Lambda can scale quite quickly. And do you want to see something more? Or do you have any questions? Yeah.
What version of Golang do you use?
Like 1.x, so I would say
So
if they say like one.
Past 4 years, so you
Yeah.
know what you
I use 1.9, and it works. I don't know if there are limitations.
Yeah, some differences. But you know, what front end is if the better it's running with SQL, it's running with
Okay. I don't know.
What you are uploading is the created binary or
Yeah. That zip file.
And there is a binary.
Yes.
So it's running out of binary in the alias file. It's not running from the source code. It's not rebuilt. It's
Yeah. You have to
no
build it.
binary.
Yeah. You have to build it by yourself. Like for other languages, for scripting languages, you are sending their the source code, but you have to probably build it yourself.
So actually it doesn't matter because you are not using any compiler at all on the Amazon
Yes.
side.
It's.
So it doesn't matter. You actually could theoretically upload any binary that conforms to some technical requirements, and you can use
Yeah.
like C code there instead of code.
Yeah. Yeah. Okay. It has to work similar to you have to mimic the start from lambda to start. Actually. Okay. So, you're serverless. It's really cool. And thank you for it.